Welcome to the first video for 3.2. This is a very long section. Okay, this is everything about slope. And there's a lot to do with slope. So we're not going to spend a lot of time really getting deep and diving in here. The only thing we're going to talk about deep is this first part here. So 3.2, last time we looked at a problem where we solved 7x plus 22 equals 50. And the answer was 4. Okay. It was very similar. I think it may have been like -4 or something. But there was only one answer. There's only one answer that fits this equation that's going to work. Okay, I can't plug in 5. 5 times 7 plus 22 does not equal 50. But if I start playing around with 50 and I change 50 to 51, the answer changes. The answer changes. We get 4.128 dot dot dot. And then if I keep doing that, if I keep changing the last number, I can get new x's each time. And what I'll see is that the x's follow a pattern, right? Since the same calculations for solving are done each time, always going to subtract 2, always going to divide by 7. What I'm going to see is the x changes very similar to the right-hand side changing. Now, if instead we call the right-hand side y, and just leave it like a generic y, then what we would get is, I'm sorry, that's a little typo, that's +7. What we get is y equals 7x plus 22, and we actually see a line, okay? This graph has the point 50 comma 4. It's right there, okay? That's where x equals 4. That gave us 50. If you go to 57, you see x equals 5. Okay, you go over to, I'm sorry, if you go to x equals 5, you get 57. If you went to x equals 6, you get 64. Okay, and so on and so forth. And if you keep plotting all of these, because we don't have to have the in-between point, right? If I want the right-hand side to be 51, that's going to be a decimal. But I get a line. And so what we call this is called the set of solutions that create a linear line. Okay, now linear is applicable here. Linear is the one we're focusing on right now. Linear follows a certain form, but the idea of a curve or a line in general, anytime you see a graph, you're not looking at a line. You're not looking at a curve. What you're looking at is the collection of an infinite amount of points all put together. You're looking at a table that has every single possible solution, because we could take the right-hand side and we can make those decimals, and we could keep going and going and going and finding every single thing that forms this pretty picture. Now that could take an entire semester in and of itself to discuss, which is super cool. But it helps us kind of connect all of these things that we were doing in 3.1 to 3.2. So that's where we're going to leave it here. The key points there is solution. Okay, we are trying to find ordered pairs as solutions. Let's take a look at this first one. Or the first equation on the next page. Here's our equation. Notice it is not 2x plus 3 equals 6. 2x plus 3 equals 6, having only one variable, would have one answer. This has two variables, meaning it has an infinite number of answers. An infinite number of answers. However, those answers do coordinate together. Okay, if I choose a variable and I substitute a number in, for example, in this case, if I substitute that x equals 6, then I have a new equation with only one variable, and therefore there's only one answer. We're going to do the same thing down here. Let's say I choose that in our same equation, okay, same equation, 2x plus 3y equals 6, infinite number of answers, but if I choose that x is -3, as stated in this coordinate pair here, remember coordinate pairs always go x, y, then I am changing this from having two variables to one variable. Only one variable, so there's only one answer. There's only one correct answer. And I can use my solving techniques from the last section to find that answer. So add 6 to the other side, we get that y equals 4. And so I can't choose just any set of two numbers I feel like. I can't be like, oh, x equals -3 and y equals 12. Woohoo, I'm done. No, they coordinate together. There is one answer depending on what you choose for the other side, okay? So I've got -3 comma -4. That is the coordinate pair that I would see on this infinite equations line, okay, on its its graph. That is the point I would see, the solution set that satisfies this equation. So a lot of big words there. Same thing over here. If I choose that in this one, notice the placement here. Again, coordinate pairs are always x comma y. So I've chosen that this time I don't know x yet, but I've chosen that y equals -4. Still has to equal 6 on the other side. Okay, still has to equal 6. Now it's a one variable equation. Now I can solve it. So I can use my solving techniques. 2x, add 12 to the other side, you get 18. X is equal to 6. All right, and we have that. That would be the solution set when y equals -4, x has to equal 6. Again, I can't choose whatever I want for both, but I could choose whatever I wanted for either and find the other one. That's pretty important. And those are my solutions. So if you see, solution is a word we use a lot in math. Pardon me, I meant to highlight that. Solution is a big word in math a lot. So if you see find the solution to the equation, that's what they're talking about. The point that satisfies this math, that makes this math true. Use the previous two examples to graph the line on the coordinate pair, and then list 3 more solutions. Here's the thing, 2 points make a line. Okay, 2 points you can connect, and that will be true. So let's go to the graph now, and let's graph these 2 points. These are our x's, and these are our y's. Same as they've always been. One solution set said that when x equals -1, 2, 3, then y is going to equal 1, 2, 3, 4. Here's one solution point. Okay, whoops, I'm going to make that better, actually, on the coordinate pair. There we go. That is a solution point. Now, the other one we had, when y was -1, 2, 3, 4, x was 1, 2, 3, 4, 5, 6. Ooh, close. There we go. And then what I can do is I thought there was a way to draw a straight line, but that's okay. I'm going to try. I can connect these 2 points. Okay. And I have not only those 2 solutions, but every solution across the graph, the infinite number of solutions. Because again, the same calculations are going to be done. Notice the similarities between these two. They're going to be done to solve these over and over and over again. And so they're going to go down at a constant rate. Okay. All right, list 3 more solutions to the equation. This graph's a little bit hard to read thanks to my inability to draw a straight line. So let's go ahead and just pick 3 random ones. I've got 2x, it's right there. 2x plus 3y. I think I'm going to choose 0. Why not? I don't know, choose 0 for y, and then 1. See what happens. If I choose 0 for x, then I get 2 times 0 plus 3y equals 6. Cool. See, this is why I like 0. 0 makes it cancel out. Boop. And then divide by 3, we get that y equals 2. So there's one more. Do it again. If I choose 0 for the other spot, though, that gives me 2x equals 6, and so x equals 3. Notice that's not quite the same thing. Yeah, my graph is not right here. Hold on. Let me rearrange my line. I could put those on. Oh, I'll do it in a second. Let's do 1 as well. I've got x equals 1 plus 3y equals 6. I've got 2 plus 3y equals 6. Okay, that didn't cancel out. That was kind of sad, but that's okay. Subtract, you get 3y equals 4. Divide, you get y equals 4/3. Not the prettiest, but hey, whatever. Decimal answers are totally fine. Or fraction answers are totally fine. In this case, I'd go with fraction because thirds are not, they don't stop, they're not terminating, so I would go with 1 and 4/3. Probably won't use that last one to graph it. Personal choice. Might use the first 2. We'll come back and talk about why these first 2 are more special. Maybe you remember, maybe you don't. But if you notice, if I drew a straighter line, 0, 2 is right there, and 0, 3 is right there, and this one, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, would have been a much better line. There we go. Okay, and so, I mean, obviously, the more points you draw, the easier it is to do. We would have gotten the straight line, the infinite set of all the solutions. Cool. Alrighty. This is called standard form. This is not the way our first equation was written. right? Our first equation was written differently, but when it's written with both variables on one side, now you are going to have to memorize this, so please highlight it. Both variables on one side, this is called standard form, okay? All the variables have to be on one side. Now, there's a little bit of debate whether about that last number is negative or positive, depending on which class you go to, so I'm going to leave that up to you, but all the variables on one side and preferably no fractions, okay? We saw in the last video maybe how to fix that, but if you need some help, let me know. That's called standard form. Next up, in the next video, we're going to talk a little bit more about these two guys here, the 0, 2, and the 3, 0, why they're important. If you have any questions, reach out to your teacher.